Okay, so today we're going to start the process of creating the graph of sine and cosine. And the first thing we're going to do is just use the unit circle to fill out our table at the top of your notes. So the table is in radians, and it starts in the negatives. Negative 2 pi, which would be the same as negative 360, or at the location 0. So we want to think about what our y value and our x value are for sine and cosine. Remember that cosine is our x from the unit circle and sine is the y. So at negative 2 pi, our cosine, our x value is 1, and our y value, our sine, is x. Okay, and I'm just going to go ahead and fill these in. Negative 3 halves pi, 1 for sine, 0 for cosine. At negative pi, we have negative 1 as our x value, and 0 is our y value. And we're just continuing to rotate, negative 1 and 0 and negative pi over 2. Then we're back at 0, so we're back at 360 degrees in the 0 spot, and we're at 0, 1 again. Okay, as we move on, pi over 2 is at 1, 0. Pi is at 0, negative 1. 3 pi over 2, negative 1, 0. And then we're back at 2 pi, and we have 0, 1. Okay, now we're just going to move on down and actually plot these points on our sine graph and cosine graph. So at negative 2 pi on sine, we were at 0. Okay, and one thing I'm going to add is that our scale is actually going to be 1/2. So as we get up, 2 marks up is going to be 1, and then 2 marks down is going to be negative 1. Okay, so then at negative 3 pi over 2, we are already up at 1. And then as we get to negative pi, we're back down at 0. Negative pi over 2 goes down to negative 1. At 0, we are at 0. Then when we get to pi over 2, we're up to 1. At pi, we're back down at 0. At 3 pi over 2, we're at negative 1. And then at 2 pi, we're back to 0. Okay? We can then connect these dots, and we make what we call our sine curve, which is just up and down from 1 to negative 1. I'm missing a few points here. It's a little difficult on this application. But as you can see, it just fluctuates, reaching a high point of 1 and a low point of negative 1. Okay? And it gets back up to that max, that 1, every 2 pi. Okay? So we're actually going to call that our period. Period, because that's the period of time, or the period of measures that it takes to reach a full 2 pi cycle. Okay, now let's go ahead and do the cosine graph. At negative 2 pi, we start out at 1. Okay, so this time we're starting up, whereas last time we started at 0. Negative 3 pi over 2, we're down at 0. Negative pi, we're down at negative 1. We're going to go ahead and fill these in again. It's going to be a similar type cycle, but you'll notice that at 0, we're up at 1 instead of being at 0. Okay, so similar process, similar looking curve, reaches the low point at negative 1, goes through 0, hits a high point of 1, back down through 0. Okay, and once again, we have a 2 pi period. Okay, it went from, each time it hit the max 1, there was a 2 pi gap. Okay, let's start covering some of the vocabulary now. Okay, so periodic function is just a function that repeats on a regular interval. And we call this regular interval a cycle. Okay, I'm going to go ahead and get all these written down and then we can talk about them. It's a little difficult for me to write them while we talk. Okay, so I took a second to go ahead and fill in the vocab. Why don't you guys pause your computers and go ahead and do the same thing I did and just go ahead and fill in the vocab as well as possible. So pause it now, fill it out, and then come back and we'll talk about it. Okay, so you should have it filled out. And where it talks about periodic function, all that's talking about is this function, is it periodic? Is it on a normal cycle? And as you can see, this does cycle through. It just kind of repeats, right? And we call that cycle a period. And that's the length of time it takes to go through an entire cycle. So we usually use like the maximum as a marking point on the ones above. And it took 2 pi of distance to go through an entire cycle. Okay, the amplitude is typically equal to the maximum height. Okay, unless there's been a shift, a vertical translation, it's going to be just the maximum height. But really, it's half the distance between the max and the minimum. Okay, x-intercepts and y-intercepts, nothing new there. You guys are familiar with those. On just the normal parent function, y equals sine x and y equals cosine x, you see those listed there. You can also see them above. But those will change as there are transformations. For the sine x, it will always cross the y-axis at 0, 0. And cosine x will change depending on what the amplitude is. Okay, sine x is always an odd function. It's symmetrical about the origin. And cosine x is always an even function, meaning that it's symmetrical about the y-axis. All right, so we'll go ahead and do an example here. As you can see, the graph is already completed. Okay, and all we're trying to do is recognize whether or not it's a sine function or a cosine function, find the amplitude, the period, and the y-intercept. Okay, so this one, I can see that it is not symmetrical about the origin. It is symmetrical of the y-axis. It doesn't start at 0, 0. In fact, it starts at about 1/2. So at 0, 1/2 is where it crosses the y-axis. So I know this is the cosine function. Just putting those together. The amplitude, the max height is 1/2. The min height's negative 1/2. So half of that distance is just going to be 1/2. The distance. When I say half that distance, I mean half the distance between 1/2 and negative 1/2, which is a full 1. So half of 1 is 1/2. The period is going to be pi, and the y-intercept is 0, 1/2. Okay, and it is pi because we starts at 0 and ends at pi there. It took a full pi cycle to go to reach that 1/2. Okay, let's move on to the second one. As you can see, this crosses the origin at 0, 0. It is symmetrical about the origin, so we do know it's a sine function. Okay, the amplitude varies from 2 to negative 2. So again, that distance is 4 between 2 and negative 2, and half of 4 is going to be 2. Okay, the period, the distance it takes to complete its full cycle. A little more difficult to look at on the max. So I'm going to go find another point here where it's on its way down at pi over 4, and then you'll see it again is on its way down at 3 pi over 4. Okay, So that is a complete of a full cycle also. So 3 pi minus 4, or 3 pi over 4 minus pi over 4 would be 2 pi over 4, or pi over 2 would be the period. Okay, it takes about a half pi period to go through a full cycle. And the y-intercept is at the origin, so that would just be 0, 0. Okay, so go ahead and try these out on the practice work. I'll put the answer key up so you can check your work and make sure you're tracking well. I'll be back on Monday to take any questions. Thanks.